Hello students, Callie Daniels here. In this video, we will add and subtract rational expressions. First, let's begin with an illustration where we add or subtract some fractions as indicated, and we will always write our answers in lowest terms. That is, we will reduce them. In part A, these fractions are alike because they already have a common denominator. And as we just think visually about what's happening here, if we take a whole thing, maybe a whole pizza, and slice it into 4 equal-sized slices, then adding 1/4 of the pizza to 2/4 gives a combined 3/4. When we add or subtract fractions, we add or subtract the numerator and keep the same denominator. In part B, in order to add these fractions, we need to obtain a common denominator. Considering 10 and 15, our lowest common denominator is 30. That's the smallest number that is a multiple of both 10 and 15. Let's build up each of these fractions. Multiply 1/10 by 3/3 to obtain 30 in the denominator. Multiply 2/15 by 2/2 to obtain 30 in the denominator. This gives 3/30 plus 4/30. Adding in the numerator gives 7/30. So we're just setting up a process for adding and subtracting rational expressions because it's done in the same way that we add and subtract numerical fractions. In part C, looking at our denominators 3 and 8, we can determine that the lowest common denominator is 24. Multiply 7/3 by 8/8. Multiply 2/8 by 3/3. Notice that each of these fractions in red has value 1. So we're just multiplying fractions by 1, changing the way they look, but not changing their value. Let's see, our first fraction becomes 56. 24ths minus 6/24. Subtracting in the numerator, we have 50/24. And this is going to be, we can reduce this. Each of those numbers is even, and so we know that there's at least a factor of 2 involved. 50 is 2 times 25. 24 is 2 times 12. Dividing out the common factor 2, we obtain our reduced answer, 25/12. That is our pattern. Now let's proceed to add and subtract some rational expressions. So let's throw some variables in here. We're going to always write each answer in lowest terms. Part A, hey, this is no problem. Those denominators are already the same. Add in the numerators. So we will add 3 plus 6. That's 9/r. And with our second fraction, those denominators are the same as well. So this shouldn't be a problem for us. Let's add in the numerator. Z² minus 10z plus 25 all over z minus 5. Now we want to write our answers in lowest terms, and this one will reduce because the numerator is a perfect square trinomial and it factors z minus 5 times z minus 5, or you might write that z minus 5 quantity squared. And if we divide out a factor of z minus 5 in both the numerator and denominator, we obtain z minus 5 over 1, or just z minus 5. You can also think of this as using our quotient rule and subtracting exponents. 2 minus 1 is 1. as we continue with example 1. In part C, we've got a subtraction problem and the denominators are not the same. Well, here our LCD is every factor that we see. We see m and we see m minus 1, or excuse me, m plus 1. So our LCD is m times m plus 1. Let's create that LCD for both fractions. Multiply 3 over m plus 1 times m over m. And let's multiply 4 over m by m plus 1 over m plus 1. So in this case, each of those fractions has the same common denominator, m times m plus 1, and now we just clean up in the numerator. Multiplying, we've got 3m minus symbol. Now be careful here. Actually, we want to take negative 4 and distribute it to both the m and 1. So let's write minus 4m and minus 4. Be careful there with your minus symbols. Combining like terms, 3m minus 4m is negative m. We also have minus 4 in the numerator, all over m times m plus 1. This will not reduce, as there are no common factors to divide out. Part D. This is unique. Notice that those denominators are opposites, aren't they? And so we can choose either denominator as our LCD. I'm going to choose 4p minus 5. I prefer it because it's in decreasing degree order, and it's common to write expressions in decreasing degree order. Well, our first fraction is as we want it. It's got the desired denominator, but that second fraction does not. Okay, we need to change the signs in the denominator. So let's multiply the second fraction by negative 1 over negative 1. Thus, we have 3 over 4p minus 5 plus 9 times negative 1 is negative 9. And notice what happens in the denominator. So we distribute negative 1, we obtain negative 5 plus 4p. And negative 5 plus 4p is the same as 4p minus 5. And so our denominators are the same now, and we can subtract in the numerator. 3 plus a negative 9 is negative 6. That's all over 4p minus 5. Now, if you had chosen to use 5 minus 4p as your LCD, you would have obtained an equivalent answer, positive 6 over 5 minus 4p. And either of those is a correct choice for your answer. Continuing with this example, adding and subtracting. Let's see, in part E, before we determine our LCD, we need to do some factoring. So let's factor this first denominator. That's k minus 4 times k minus 1. Second denominator is the difference of squares. It factors k plus 1 times k minus 1. Now our LCD contains every factor that we see. We see k minus 4, k minus 1, and we see k plus 1. We see that k minus 1 again, but we've already gotten it, don't we? LCD contains every factor that you see, along with greatest exponents. Now let's build these fractions up. Our first fraction, 2k over. Now, once you have your denominators in factored form, keep them in factored form. So I'm going to use the denominator k minus 4 times k minus 1, because we can easily compare that to the LCD and see that it's missing the factor k plus 1. So multiply numerator and denominator by k plus 1. Moving to our second fraction, 3 over k plus 1 times k minus 1. We compare it to the LCD and see that it's missing k minus 4. Multiply numerator and denominator by k minus 4. So we're sitting in a really good spot here. Both of our denominators are the same, so I'm going to write one long fraction bar and just write that denominator one time. And write our numerators over that and begin to do some cleanup. Multiplying, we have 2k squared plus 2k, and multiplying with our second fraction and using the distributive property here, we have 3k minus 12. Combining like terms in the numerator gives 2k squared plus 5k minus 12. That's all over k minus 4, k minus 1, k plus 1. Don't let that denominator disappear on you. Okay, it needs to remain in our answer. So we've completed our addition. Our last question is, I wonder if this is going to reduce. That is, can we factor that numerator? And if we can, will we be able to repeat any factors of the denominator? Well, that numerator, if it does factor, it'll factor as the product of two binomials. And up front, we would have to use 2k times k to obtain 2k squared. Now our only question is what are factors of negative 12 that we can pair in here. And if we use minus 3 and plus 4, our inner product minus 3k combined with the outer product plus 8k gives 5k. But notice that we don't get to repeat any of those factors from the denominator, and therefore this is not going to reduce. Now, as you write your answer, you can write either of these last two forms as both are correct answers. And lastly, still adding or subtracting. And in part F, we need to factor denominators. This first denominator is a difference of squares. It will factor a plus 1 times a minus 1. And our second denominator is a trinomial, and if it factors, then the first terms of those binomials must both be a. Factors of negative 4 that sum to 3 are plus 4 and minus 1. Our LCD contains every factor that we see. We see a plus 1. We see a minus 1. We also see a plus 4. So let's build up each of our fractions so that they have that denominator. Again, once you have factored those denominators, keep them in factored form. Save yourself some time. As we compare this denominator to the LCD, it's missing a plus 4. Multiply numerator and denominator by a plus 4. As we look at our second fraction, a minus 1 over a plus 4 times a minus 1, and we compare it to the LCD, it is missing the factor a plus 1. Multiply numerator and denominator by a plus 1. All right, we've done some really good work here. We have common denominators, so let's just write that denominator one time. And let's go about combining our numerators. Up front, distributing the 1 gives 1a plus 4 or a plus 4. Now be very careful with subtraction here with our second term in the numerator, okay? We want to apply this negative symbol to everything that follows it. So I'm going to open a parenthesis to tell myself to apply that negative symbol. Now as we multiply, using our FOIL method, a times a is a squared. Our outer product is plus a, the inner product is minus a, and those terms cancel out. Negative 1 times 1 is minus 1. Numerator then becomes a plus 4 minus a squared and plus 1. So again, be very, very careful with your signs in the numerator. Last step, let's combine like terms in the numerator, and I'm going to rearrange those terms so that they are in decreasing degree order. So let's write minus a squared plus a. 4 plus 1 is 5. All over a plus 1, a minus 1, a plus 4. Now as a last thought, our question would be, I wonder if we can reduce this, that is, write it in lowest terms, but that numerator is not factorable. Therefore, we know there will be no common factors to divide out, and that answer is indeed in lowest terms. We have in this video added and subtracted fractions. To do this, we need a lowest common denominator. Good luck with these.